Welcome to week 7. Last week you built the API side of features 2 and 4, which are the update user and get all trips by user endpoints. This week you build the client side for feature 2, which is that edit profile page flow. That means the actual web page the user will see and interact with, and we've been talking about this 5-step pattern. And at this point, steps 1 through 3 should feel familiar from our previous work in weeks 5 and 6. This week, we're going to put all 5 steps together and write both controller methods and the Razor view. So by the end of lab, you'll be fully working end-to-end with your edit flow. Before we really dive into this, let's make sure that 5-step pattern is clear. Steps 1 and 2 are constant values and our response models. These should already be in place from prior work. Our getUserById and updateUser constants exist. User response model and saveUser response model exist. And then steps 3 through 5 are what this week is really about. Step 3 is the controller method calling service helper, one get method, one post method. Step 4 is deserializing the JSON string into a typed model. Step 5 is passing that model to the view and rendering it. Notice the pattern is really always the same shape, regardless of what feature we're building. And every time we add a new client feature this semester, run through these 5 steps. And hopefully by the end of this course, they feel pretty automatic. Just a recap of what we've talked about previously are 2 controller methods, get and post. Edit profile needs these 2 methods because it has 2 distinct jobs. The get method loads the edit form. The user clicks the edit link on their dashboard. We pass the user ID in the URL. The get method uses that and calls getUserById on the API. We get back a user object and pass it to the edit view, so the form fields are going to be pre-populated with the current user data. It uses getRequest via the service helper. So the user, when they load the form, can now see, here is all the data that Megatravel has about me. Now I can decide what needs to be changed, and so the user can edit one or more of those fields, and then the post method handles the submission. When the user is finished and they click save at the bottom of the form data is sent back as a post. The post method serializes that updated user object to JSON, calls update user on the API, and on success redirects back to the dashboard. It uses post request. So get is for reading data, post is for sending data. This feature uses both, which it has 2 methods with 2 verbs to handle that. So the question I often get when we're building this feature is, why fetch fresh data? We already know the user's ID from the session. So why call getUserById at all? Can we just use whatever data we have? So to answer that, we have to look at what session actually stores. In this case, it's account ID and the authentication token. We don't store first name, street, phone, or any of those profile fields in the session. Storing the full profile in the session would mean keeping session data in sync every time it changes, which does create complexity and could invoke some bugs. When we do store it, if we store it in the session, there is the issue with the data being stale. So if the user logged in on their phone an hour ago, updated their profile on a different device, the session data on the device they're logging into is now out of date. So the database is really always our source of truth. And then we want consistency. Before editing anything, we should always fetch the latest version. And, sometimes we use an analogy of a shared document, like in a folder, you don't edit your cached version from last week. You open the file and you get the latest and you edit from there. So this is really the same principle that we're working with here. So let's walk through the edit view. The first line we can see here is @model_user, which makes the view what we would consider to be strongly typed. Razor, the engine that we use for writing these views, knows that at compile time, the model has all of the properties of the user class. So a user ID, first name, street one, all of those other user properties. If you misspell a property name, you'll get a compile error, not a runtime error. The compiler knows what those properties should be. Inside of the form, you need what we call an anti-forgery token. This is a security measure that prevents cross-site request forgery. We always include it in any form that has post data, no exceptions, and then a hidden for the user ID. This is so important, it's basically going to get its own slide, but the short version is the user ID has to be included in the post. We don't want the user to try to edit it though. They don't even really need to see it. Edit for is what's going to generate the input fields pre-filled with the current value from the model. So when the user changes it and submits, the new value replaces it, and the cancel button uses an ASP action to navigate back to the index without submitting anything. Then we can see that there's an @section scripts at the bottom that loads in anything we might want for client-side validation. It catches things like empty required fields before the form is even submitted, saving us a round trip to the server. So, hidden for kind of a deep dive. The most common mistake on this feature, and to be clear, like it happens quite a bit, what happens with that hidden for? So the form submits whatever fields have visible input elements. User ID doesn't have an input field, and we don't want one. It's just a property on the model. It's fixed. The user can't change their user ID. So when the form is submitted, user ID comes through as 0. The post method passes update user to the API with user ID equals 0. Update user record calls single or default async looking for a user with ID 0. There's no such user. The update just fails. So the hidden for renders an actual HTML input element with type equals hidden. And if you've worked with HTML forms at all before, you know that type hidden is how we usually include things in a form in the browser that we don't want to have a visual component. So the browser will include it in the form submission like any other field, but just doesn't display it on the page. And that is what's going to make sure it gets included when the post method gets sent. And now we would get user ID of 1, and the API knows exactly which record to update, and user ID 1 actually exists. So any ID on the controller needs to be the user, but we don't want to see it, we don't want to edit it. And if there are any other fields in the future that maybe need the same behavior, you need to make sure they get included with a hidden for so that when the HTML is rendered, it will have that input type of hidden. So let's see how to handle the post response. After calling our update user, there are 3 possible outcomes, and we have to be prepared to handle all 3. The first scenario is save response is null. This happens if the API is maybe unreachable and the response string can't be deserialized. This null check is going to catch that. We want to show an error message and return the view with the user's input just intact. The second scenario is that save response.status is false. The API responded but reported a failure. Maybe a record wasn't found or there was some kind of database error. We would have to dig in and be more explicit if we wanted to learn more. but we want to basically perform the same response. Show the error, return the form, nothing got updated. The third scenario is the success. If save response returns a true, then we know everything worked. We want to redirect to the index action, and that call out there explains kind of a key user experience detail. When we return view with an object in the parentheses, on failure, you're passing the user's partially filled form data back to the view. They get to see what they typed, and then, you could surface up and maybe they need to fix a problem. If you returned a blank form, they'd have to type everything again. So it's a small detail, but it could make a real difference to just user experience. Users are going to notice when their data disappears, and it can be very frustrating. So let's talk about this post redirect get pattern. And I really want to make sure the redirect to action decision that we're making is clear, because really sometimes students try to simplify it and just return view and then encounter strange behavior. So take a look at the left column without our post redirect get. The user submits, the API saves, controller returns view, right? Just view with nothing in the parentheses. The dashboard renders. The user presses refresh, and the browser is going to ask, should I resend that post request? And it will. And so then the data gets saved again. So in a financial application, that could be a double charge, or now we have two records up, like saved or added, or it just causes a lot of problems. In Mega Travel, it probably would just create some unexpected behavior. But at the right column, what we want to do is the user submits, the API saves, the controller calls redirect to action, and the browser follows the redirect to get the user index. Then if the user pressed refresh, the browser just resends the GET request and everything reloads, but it doesn't have that post request data being held in its header cache to where it could try to resend that. So it would just reload the dashboard, and that's totally safe. So the standard, really the rule that we want to follow, is anytime a form submits data and succeeds, redirect instead of trying to render. And anytime you have a post, think of this pattern that modifies data throughout the rest of the semester so that you don't create scenarios that might harm your data. So here's the complete controller code so we can understand the flow and the implementation side by side. The GET method has 3 steps. We create the service helper, call the GET request with our GET user by ID and the user ID from the query string. We deserialize into the user response model, and we return view with the user data. The post method has a similar structure, but with the post request. We serialize the incoming user object to JSON first, then we call post request with update user. We deserialize into a save user response model, check status, and redirect or return based on the result. The 4 little boxes at the bottom walk us through kind of our mental model. GET uses GET request. Post uses post request. If the operation fails, return the view with the model. If it succeeds, redirect. So for every feature you build this semester, the structure of the GET method never changes. Only the endpoint name and the response model type changes. So I know as we go through these weeks, things will start to feel like I'm repeating myself, but it really is to build repetition, because we look at software systems like Mega Travel, which again might be the biggest project you've ever seen, but is very small in terms of what real world software actually looks like. But what I'm trying to impress upon you is the idea that these systems are built around patterns, and we have a very identifiable way of determining how something should happen when we're writing a new feature. So for lab this week, we're going to confirm our constant values are correct for the endpoints that we've built so far. We're going to add response models to the client-side models folder. We're going to write the edit get method. We're going to write the edit post method. We're going to create the edit view with the features that we've discussed. We're going to test end to end. So we're going to log in as Susan S., click the edit link on the dashboard, change something like the phone number, save, confirm the change persisted, go to the database and look at it, pull it from Swagger, whatever you have to do. But when we can see that the data actually saved to the database, then we know the whole stack is working. And then on the right, we can see a quick preview of week 8. That's our feature number 4 client side for view all trips. That'll be a very similar get pattern to what we've been doing this week, but instead of a form, you're building a table. And so some new challenges in just displaying the related data on the view and handling some different cases and making sure that our get all trips by user API endpoint is verified in Swagger before we get started on that. So I will see you in lab for next week.